We will read the question first. So we have, keeping water supplies clean requires regular measurements of levels of pollutants. The measurements are indirect. A typical analysis involves forming a dye by a chemical reaction with the dissolved pollutant, then passing light through the solution and measuring its absorbance. Okay, so the pollutant here is nitrate. And to calibrate such measurements, the lab measures known standard solutions and uses regression to relate absorbance and pollution concentration. So here, this sentence tells us that there is a relationship between the pollutant, which is the nitrate, and absorbance. So these are the two variables. So this is usually done every day. Here is one series of data on absorbance for different levels of nitrates. So nitrates are measured in milligrams per liter. So mg per liter. So the nitrates, the way the calibration is done is the nitrates levels are fixed in the solution, and for each the absorbance is measured. Okay, so this is how the calibration process is done. You change the nitrate levels and measure the absorbance of light that passes through the solution. But this is the important part. What do we want to do with this relationship between nitrates and absorbance? We would like to use the relationship to be able to predict nitrate using absorbance. So this is an important sentence. So this tells us that we want to predict nitrates, which means nitrate is Y and absorbance is our X value, which means nitrate is the response variable, or it's also called the dependent variable, and X is the absorbance, also called the explanatory variable or the independent variable. So this is the sentence that helps us decide which one is explanatory and which one is response. Initially, this table almost makes us believe that nitrates is X and absorbance is Y, but this sentence is basically giving us the exact information here. So data points are given. So data are given, nitrates versus absorbance table is given. We put absorbance as our X value and nitrates as our Y value. And this is what the scatter plot looks like. And from the scatter plot, can we decide the form? Form is the shape. What is the general shape that is forming? And it's clearly a straight line. So the form is linear. The points are almost lining up to form a straight line. The direction is positive because the line is going up. It's a rising line. So the direction is positive. And what that means is as absorbance increases, the nitrates decreases. The strength, it's extremely strong because the points are almost forming a line. We rarely see this. And we've already seen that the explanatory variable is absorbance and the nitrates is the response variable. Now let's see the next question. Is it appropriate to calculate R, which is the correlation coefficient, and Y? And the answer is yes, it is appropriate to calculate the correlation coefficient. Why is it appropriate? Because the form is linear. Why? Because the form is linear. If the form were not linear, then it would not have been appropriate to calculate R. Now, chemical theory says that these data points should lie on a straight line. If the correlation is not at least 0.997, something went wrong and the calibration procedure has to be repeated. So we did plot the graph, which is the scatter plot, which tells us it's linear. And that's the reason why we want to find the correlation, which is a numerical summary that describes the strength of the linear relationship. And when I use my calculator, I get 0.9999. Make sure you know how to use your calculator, because on an exam, you do not have access to any sort of software. You'll have to depend on your calculator to find R, the regression line, median, mode, whatever, mean. So the correlation R is 0.99999. So the calibration process sets the nitrate level and measures absorbance. Okay, so based on the nitrate level, you get absorbance. But once that is done, the linear relationship will be used to estimate the nitrate level. Whatever we're trying to estimate is our Y, and it sits on the left side. And we want to estimate the nitrate level from a measurement of absorbance. So given the absorbance, so given X, we'll find the nitrate level, which is Y. Now, enter all the data into your calculator. Make sure your X, which is your first column, is absorbance. That is your L1. And L2 is the nitrate level. Okay. And make sure that you're trying to find the linear regression AX plus B or A plus BX, whatever it is, whichever one you use. Make sure your X is absorbance, your L2 is nitrate level. And that's when you get the correct equation. I would suggest do this on your calculator. Make sure you're getting these numbers. Next, what is the estimated nitrate level in a water specimen with absorbance of 40? So we're going to, how do you find the estimated nitrate level? By using the regression equation. So substitute, so nitrates is equal to negative 14.52 plus 8.825 times the absorbance, in this case, is 40. Why am I able to plug in the 40? Let's go back and look at the data set. Remember that we're going to use the equation to plug in the absorbance, that's your X, and figure out the value of Y, which is nitrates. Notice that the range of values within which the data were collected is 7.0 to 226. Okay. And the regression equation depends on these X and Y values. So we are able to predict the values of nitrate when the absorbance level is anywhere between 7 and 226. So 40 lies within this interval. Therefore, we are able to predict the nitrate level for an absorbance of 40. However, if the absorbance is outside the range of these collected data, which is from 7 to 226 absorbance, then we cannot use the regression line to make a prediction. The regression line is valid only between 7 and 226. That's the values of X. You can plug in any number within this range, but if it's outside that range, then we are not able to estimate. So notice, if the absorbance is 350, now obviously that lies outside the range of values of absorbance collected. Absorbance is the X. It is outside this range. It lies outside, which is because it's greater than 226. So therefore, we are not able to make this prediction. However, we can make the prediction for 40. Simplify this using your calculator to get 338.48 milligrams per liter, because those are the units given in the question. So let's just quickly go over this. We cannot plug in a 350 because it's outside the range of values of absorbance collected, outside the range of the data collected. But we can plug in a 40 because it is within this range, 7 through 226. So the absorbance value, you can't just plug in anything you want. It has to be within the range of the values of absorbance collected. Do you expect the estimates of the nitrate level, because that's what we're estimating, from the absorbance to be quite accurate? The answer is yes, absolutely, because the correlation is very, very strong. The closer it is to 1, the stronger is the correlation. Since it's a positive correlation, we're looking at the numbers close to 1 to call it a very strong correlation. The last question is, what percent of the variation of the nitrate level can be explained by the absorbance? So what percent of the variation of the response variable can be explained by the explanatory variable? Here is when you need to figure out what R squared is. So 0.9997 the whole squared. I'm sorry, this should have been 9999, not 9997. So this is 0.9999 whole squared. And we get 0.9998. We change this to a percent, so that's 99.98%. So the 99.98% of the variation in the nitrate level can be explained by the absorbance.